Okay, so factorising is a slippery topic because it can be hard to know what to do, especially when you've got so many expressions that look fairly similar. So the first thing that I want you to do every time when you're factorising something is to look for the highest common factor. If you can find a highest common factor, that's always the first thing you should do. So write the highest common factor on the left. So let's do that with this one. Can we find a highest common factor? Now, if we look at the numbers, 5 and 30, the highest common factor of those two is 5. So that means we can at least write 5 here. Now, if you look at the letters, both of them have a B, and we've got two A's multiplied together here, and one A here. So in common, they have an A and a B. Now, to get what's inside the brackets, you have to divide each term by this. So if you divide it, the 5's cancel out, the B's cancel out, and you've got one A left here. If you divide this term by this term, 30 divided by 5 is 6, and the A, B's cancel out. So that's it. All right. Now, let's look at the next one. Is there a highest common factor? No, there's not. Because these two have x's, but this one does not have an x. And there's some factors of 10, but they're not here. So, we have to think about monic quadratics, and there's a video on that. And hopefully you remember that we have to have two numbers that add to, we'll call them A and B, add up to give this, and they times to give this. A times B equals 10. A plus B equals 7. So what's A and B? Let's see. Well, the quickest way to do this, I find, is to look at the factor pairs of 10. So if you remember, we wrote down some factor pairs. For example, 1 times 10 or 2 times 5. That's actually it. 3 is not a factor of 10. 4 is not a factor of 10. And then we're back to 5, which we've already got. So now we can start adding these up. Maybe that's A, and maybe that's B. We don't know. Well, 1 plus 10 equals 11. Whoops. What is happening? All right, 1 plus 10 equals 11. That doesn't work because we need 7. 2 plus 5 equals 7. So that's good. That means 2 plus 5 are our A and B. And if you remember, that means we can write the factorized version is x plus whatever A is, which is 2, x plus 5. So we're done. If you want to check this, you can expand it, and you'll find that that's the correct answer. Okay. Now let's look at this one. Are there any common factors here? Well, these two have x, this one doesn't. Let's look at the numbers. Maybe the numbers have some common factors. So, if you look at the number 4, it has some factors, so that would be 4 and 2. They are the only factors that we're interested in. So, 2 is a factor of this and this and this because they're all even numbers. But is it the highest factor? Well, 4 is a factor of 40 because 40 is just 4 times 10. It's also a factor of 28 because 28 is 4 times 7. So 4 is a factor of all of them. That means we can write the highest common factor is 4 outside of here. And then we divide each term by 4 to work out what we have left in the brackets. So the first term you get x squared. The second term, I said it's 28 is 4 times 7. So that has to be 7x. And the last term, 40 is 4 times 10, so it's 10. Okay, now, unfortunately, sometimes with factorising, there's more than one step. Because I have factorised it, true, but I can factorise it further because I can also factorise what's inside the brackets. And you should know that because this is exactly the same as what we had in the previous question. So instead of that, we write the factorised version, which is this x plus 2 x plus 5. And now finally, we're factorised fully. We can't do any more factorising here. Okay. Now let's throw all the tricks we can at this. Is there a highest common factor? Factors of 9 are 3 and 3. That's it. Just 3, actually. Factors of 16, we've got 2, 4, but 3 is not a factor of 16. So this is basically, there's no common factors here. So we can't do this. We can't do this because it's a binomial, only 2 terms. And so we have to do, hopefully you saw the last video, which is using difference of perfect squares, where what we did was we wrote a little a squared and a little b squared up here. And the full rule for this is if you've got a squared minus b squared, then that's equal to, the factorized version of that is a plus b times a minus b. Hopefully I got that in. So if we can work out what a is and what b is, then we can work this out. We can factorize it. So a, that's a little bit tricky. Something squared equals 9x squared. So that would actually be 3. You can look at the numbers and the letters separately. For the numbers, 3 squared equals 9. So you've got 3. For the letters, x squared equals x squared, of course. So the whole thing, if a is 3x, that works because a squared is 9x squared. And b is a little bit easier. B is just 4 because 4 squared equals 16. Okay, so this whole thing, and if you didn't get that, you might need to rewatch the video on difference of perfect squares, or ask somebody for help about this particular question to go through it more slowly. So for this one, you have to just write down a plus b, a minus b, but instead of writing a and b, you write down what a and b are in this example. So a is 3x, so instead of writing a, you write 3x. Then you've got plus b, which is 4. 3x minus 4. And that's it. Okay, so number 1, first thing, look for the highest common factor. Number 2, see if you can use a rule like this, or perhaps use this method of the quadratic trinomial, which we're using here. All right, thank you for watching. See you next time. We've got one more video in this series, unless I decide to make another one, which is definitely possible.